Okay, we are entering movie reviews for sentiment analysis just like we did last time with our Tiny BERT implementation, and we're getting kind of the same results that we got last time. We're getting nice positive and negative classifications on our movie reviews that we type in, but this time we're actually going to be getting some different results because we changed our model that we trained from Tiny BERT to Small BERT, and that's going to make a difference. As you can see here, that movie was meh. Last time it misclassified that as a positive review, and this time we're getting the correct answer, which is a negative review, as things get a little more accurate as we configure our model to get better and better. Let's go see how to do that. I'm your host, Sean MacKenzie. Thank you for joining me once again on my channel on data engineering. In this episode, we continue our journey into sentiment analysis and our artificial intelligence playlist, and more specifically our BERT playlist. And we're going to take a look at how to move our BERT implementation from Tiny BERT, which is a small pre-trained model, to Small BERT, which is a much more powerful and larger model. Now, you might be surprised at just how much difference changing the size of our model from a Tiny BERT implementation to Small BERT, and in future episodes a full BERT implementation, actually makes. Let's get to it. Interested in more cool topics like these? Make sure to check out my Patreon. The link is in the description. Okay guys, this is a fun one today. It's always fun when your script is all done and you just need to do tweaking and some trial and error in order to see what kind of changes you can make to your outcomes. Okay, scroll down in your script there to where we have BERT model name, and we are going to take this Small BERT. Now this is the Tiny BERT implementation, has these sizes on the end of it, and if we scroll up we can see all the different sizes that BERT has attached to it as part of this mapping. And in general, the higher the numbers, the more powerful the model, and the more processing it will take in order to do your training and those kinds of things. And so if we jump up and grab the name for the Small BERT implementation, which is the L4H512A8 model, that is going to allow us to use the Small BERT implementation. It's going to expand the amount of resources and things that we are using when we run our model. So all we have to do is grab the name that we want, and we can replace this other name that we put here for the Tiny BERT implementation. So I'll comment out our Tiny BERT name and I will paste in the Small BERT name, and that's all we really need to do to change the size and power of our model. And you'll see much more activity up here in the CUDA section when we run our script because it is going to use quite a bit more power and resources in order to train the model, and it should go a fair bit slower than when we were training with Tiny BERT. Now we're going to change our epoch to 3. We did 5-epoch when we trained Tiny BERT, but we're going to change our epoch to 3. We're only going to do 3 with the Small BERT model, and I've advanced our console here to push all of our Tiny BERT training off the top of our console there, and we're going to go ahead and grab the same command that we ran before to run our script. And that's really all we need to do in order to change the size of our model. So you can see now that we have our script ready, we can change it and we can run all kinds of different models. And in fact, I also ran Electra and a couple other ones which were pretty cool and gave slightly different results. And so just like we saw before, our script is going to go, it's going to retrieve that sentiment data. It's already cached, and so it's already started loading that data because we downloaded it the first time, and it gets cached for subsequent runs of your script. And let's see what we get. Okay, so it's already done with the sentiment data, so we should see some action here. We've got some 25,000 files belonging to 2 classes. There's the graphics card that I'm doing this particular run on, which since recording this I actually upgraded that card to an RTX 4060, so it should be interesting to rerun this with the higher level graphics card. We'll see what kind of difference we get, but for today we're processing this on our GeForce GTX 1050 Ti, and you can see the compute capability there is 6.1. I think it goes up to like 8 or something, or 9 with the RTX 4060. But there we go, we've got our model being created, and it will start processing here fairly soon. And there we go, we've got epoch 1 of 3, and we've started our compile and fit, and so it's going to start blasting away here. And it is noticeably slower than running it with Tiny BERT, especially on this card. But you can see we are getting our CUDA working there, and the GPU is firing away. So we are using CUDA quite a bit. We're getting like 89, 88, there we go, 79 in those ranges, and the CPU is working pretty hard too. So that tells us that we are working this machine pretty heavily. Typically when it's more card driven, you'll see the CPU won't be working as hard. If you're anything like me, you'll be obsessively tinkering with all of the different specifications of your machine and paying close attention to those. But definitely what we see here is our model is training nicely. I'm going to pause it here and we'll just jump right in midstream into epoch 2 here so we don't have to wait. It's sort of blasting away, and you can see that the GPU is working the same as it was before. The CPU is definitely cranking away, and we are getting a binary accuracy of 86% already, which is pretty amazing. We got 84% on the first epoch, which is already higher than our Tiny BERT implementation, so that looks promising. We're going to jump ahead to the third epoch here in the interest of brevity, and so let's just check this out. So we are getting 89% on our binary accuracy, at least in our training. The validation does not seem to be doing much better on each round, but it is still better than our previous model using Tiny BERT. And let's jump into what we've been seeing. So there's our first epoch, 84, second epoch, 84, and the third epoch actually went down in the validation, but they went up from 78 to 86 to 90 in training, and so that could be a result of some kind of overfitting or something like that. Definitely we are doing better than our Tiny BERT implementation, where we got around 78, I think was our final number there. And I can just skip to the end here. We can see that our binary accuracy has gone up tremendously, and it looks like our training loss is what we would expect to see, not the validation loss. The training accuracy is what we would expect to see, going up nicely there. After 2 epoch, it looks like it wasn't getting more accurate, and that's pretty common for BERT. So sometimes people only train 1 or 2 epoch with BERT before it overtrains, because it's a pre-trained model. And so here we go, we can try this out. We can say, you know, that was a really interesting movie. I like the way the characters developed, and we can see what kind of classification we get from our model here. And so let's check it out. So we got entry 1. That review is positive, and that's exactly what we want to see there. We could do something like, you know, can't believe I wasted my money on this. You know, what a waste of time that movie was. And we can do something very, very negative and just sort of baseline set here. Set a baseline for what we can expect. And there we go. So that is definitely going to be negative, and it got like a 0.001 on the return value. So that's exactly what we want to see. We could do something, you know, something in between. Movie was pretty good, but I didn't like, you know, the ending, and that's going to say review is negative. And so we definitely, I noticed using this one that it was definitely more accurate than the Tiny BERT predictions. This was an interesting movie, you know, perhaps one of the best this year. That is obviously a positive review, so we're definitely getting what we expect there, and that is fantastic. So we could do something maybe a little bit longer, you know, something about the director, and something more like the paragraphs that we see in the training data. So you may actually want to train yours, to look at paragraphs, because actually the training data is all sort of paragraph reviews. We're doing very short ones here, but let's try one that failed last time. We can definitely do that, and we should get a negative review. We should get a negative classification for the meh review, and we do. So that is different from last time. Last time we got a slightly positive review from that. Tiny BERT didn't quite get the non-language, word like meh and how it was used, but it looks like Small BERT got it. And when we train a full BERT, I think we'll definitely see something there. That was a good movie, but I'm not sure if anyone will like it. That got a negative review. I think we wrote one like similar to that last time, and it got positive. So we're definitely got one. But here's one. What a Thriller. We'll go see that one again. This one got a negative review, and so that is our first false negative there. And that is something that maybe we can try out when we go to an even bigger model, where BERT is sort of getting a little bit more of the nuances of language and how it's being used in our training data, and we can see how that works. So we got, this is an excellent example of post-apocalyptic fiction. Review is positive, and we could say something like, this was an interesting attempt at making, a historical fiction, trying some different words and saying positive or negative reviews differently. We could add something like a sentence where we're saying it's lukewarm in the first part of, the movie, but the second part was great. We could, sort of see how BERT will classify that kind of statement, since we are putting in kind of a positive and a negative sort of sentence in there. Let's see, and that is a negative review. It is actually a negative review. Who wants to go see a lukewarm first half of a movie, even if the second half is thrilling? So there we go. We've got a review is negative, and we can keep on moving here. We could say, the best and worst. We could say the best movie I've ever seen. We can say the worst movie I've ever seen. Those are going to be strongly positive or negative in our return value. And we could do, kind of liked it, but in the end was not sure. That's going to be negative. But overall, powering up our BERT implementation from Tiny BERT to Small BERT has been quite a success. And we will be very interested to see what happens when we go to the full BERT implementation in a future episode. Let me know in the comments if that's what you want to see. Are you a programmer looking for your next gig? Make sure to check out the additional links in the description.